To show you how to solve Leetcode question 572, subtree of another tree. It's an easy Leetcode question. So given roots of two binary trees, root and subroot, in this example here, return true if there's a subtree of root with the same structure and nodes value of subroot, and false otherwise. So if a tree is a subtree of the other tree, they have to make sure the four value is the same and the structure is the same. Return true. In this case, you can see that in this example, because the structure and value are all the same, so they return true in this case. A subtree of a binary tree is a tree that consists of a node in a tree and all of node's descendants. The tree could also be considered as a subtree of itself. It also considered a subtree of itself if they are the same tree. So I'll talk about this in thought process about this sentence. And if you look at this example here, there's a node 4 here, left node, right node, value all the same structures, are all the same, but however, in the root, the left tree, there's a left subtree 0, but this guy does not have any left subtree. So in this case, it returns false. And here are some constraints here. And then this last 6 months, Facebook asked this question 6 times, and you can see, although it's easy, but it could be confusing, and especially with a lot of the edge cases, if you think about like I would start with edge cases like if the root is empty, then the subroot is not empty, then I must return false in this case, because a valid tree cannot be a subtree of an empty tree, right? But if the root is a valid tree like this, but the subroot is an empty tree, then I have to return true in this case, because an empty tree could be part of a non-empty tree. So this is, you need to pay attention. And then the other thing that it mentioned that the tree could also be considered as a subtree of itself. So this sentence means that if two trees are essentially the same tree, let's say the root doesn't have the node 3 and node 5 here. If left the root and the subroot are completely identical, then you have to return true in this case. So I also have to include a scenario that where if root and the subroot are the same tree. I need to write another function to check if they're the same tree as well. The other thing is that if the root and the subroot both are empty tree, I'm also going to return true in this case, because two empty trees are definitely the same, and I have to return true in this case. And then I'm going to call this I'm going to call the same tree function to check if they are the same tree. The other thing, the rest of the algorithm is also doing the tree recursively. The recursive part is that if it's a subtree, is that I'm not going to find it from the root, right? But I'm going to either find this subroot in the root dot left, or either find it in the root dot right. That's how you can recursively call the same is subtree function to return. And if the subroot can be found in the root dot left or root dot right, either case is true, then the function will return true in this case. So, all right, let me show you how to do this in code. So if not root and not subroot, both of them are empty trees, and I'm going to return true, right? I'm just going to rule out some edge cases at the beginning. If not root, and I'm going to return false. And if not subroot, I'm going to return true in this case. The reason is because an empty tree can be part of the non-empty tree. The other thing is that if I'm going to write a same tree function if same tree of the root and subroot, if they are the same tree, right, I'm going to return true, and I'm going to call this same tree, and I'm going to call this function, and I'm going to write this function in a little bit, and I'm just going to define same tree. I'm going to pass the self and root and subroot, right? I'm going to write it later. So that's all the edge cases that I want to rule out. And then I'm going to call the isSubtree function itself to make sure I search the subroot in the root.left or root.right, whichever one that is true. So I'm going to call this isSubtree root. I'm going to search the subroot in the root.left, or if I can't find it in the root.left, I'm going to find it in Subtree. I'm going to try to find it in root.right, right? And then it's all relationship, because if I can find it either in the root.left or root.right for this root, then I'm going to return true in this function, and that's it. So this is how you do this recursively and call this. And I'm going to write the isSameTree function. So if not root and not subroot, I'm going to return true in this case, because both of them are empty, then they are essentially the same tree, right? And then there's other cases is that if not root or not subroot or root.vol does not equal to subroot.vol. I think this is super similar to one of the same tree case that we have done earlier today. I have another video to go into details about this. So these are the edge cases for the same tree. And for the same tree function, I'm also going to run this recursively, do it on the left tree and the right tree as well. So I'm going to say self.sameTree root.left subroot.left. I'm going to compare that left value and the right value. Self.sameTree root.right and subroot.right. And that's the recursive call. And essentially I want to return both of them are true, then it's the same tree. I think that's it for the code. And let's see. Great. If you think this is helpful, please give me a thumbs up and subscribe to my channel, and I'll see you with more Leetcode question. Okay, bye-bye.